Locked. Oh look, we are live. Hi. So all those on YouTube channel out there, we are live. Yeah.
Me too. Woo! Yeah, notifications.
Yeah, live. We are going live.
Where did you get the notification?
What? I got it from YouTube.
So how does it look to you guys?
Oh, are you subscribed?
Yes, I am subscribed. You know what? You know what? That's a good idea, Miss Rance. I'm gonna go to YouTube right now and look at it.
That's wonderful. Let's not watch the teacher on break. Let's watch him on a tiny screen.
Yep. Let's watch him right. Yeah.
Okay, so this is how much you're using. Take that number and divide by 2. Multiply by 100 to get your percentage.
Hey, can I?
So how does it look? Does it look like that?
Yep. It looks.
A little bit of a lag?
Yeah, a little bit.
Wait,
Awesome.
What is his? What is his?
Can you get up here and do that?
Let me see.
Hello, my baby. Yeah. No, it's actually like this.
Yeah, there's a little bit of a lag on it.
Here.
I'm really dumb. As you can tell by my green hair.
So this is one of my favorite things to do. You see me up now? I know there's a little bit of a lag.
Oh my gosh.
Am I there?
It's a lie.
There we go. Yeah, it's much smaller now.
This is one of my favorite things to do. Hey guys, I'm gonna get something. I'll be right back.
It should be on number 1 in February.
So what is I get it's live, so I've already missed it. One of my favorite things.
Yeah, it
Or
was.
you could be like, hey, whoa.
I don't like this lag. It makes me mad.
It's so funny because it's not like a huge lag. Like as soon as you do something, it takes maybe like 2 seconds for it to come
What's
back.
awesome is everybody else that's watching, they're hearing you talk as well. I mean, this is live.
Oh, that's great.
It shows-
Right? That's amazing.
You walk towards it, it shows you going down. Oh, it's so
Well, that's because it's a lag. So over here you see it in real time. I'm gonna push the button.
See in the video, you just push the button.
No, he just not pushed it.
Yeah.
What's up? You need a proof? Yeah. Okay.
Alright.
Hey Quinn, you made it.
You're on YouTube now.
Quinn, you ruined the shot. You ruined it.
You threw up your room.
Yeah, but numbers in different places.
You ruined the thing. You're in the shot.
Word.
Oh.
Yeah, congratulations, you're on my YouTube channel. Alright,
4,000.
so you're ready to get proof? Hey guys, I want to go ahead and take a moment to talk to you about your lab. Just so you know, this is live, so I have been recording your conversations.
Sweet.
That being said, yes, we're going to go ahead and get started. I'm going to talk to you about the whole setup, okay? I'm going to start with work, okay? Give me some help on what is the things that affect work.
I got you. Mass, gravity, and height.
Mass, gravity, and height. All right, so if I jot those down real quick, work is affected by mass. Well, let's do this. Mass, gravity, and we're saying what he means by that is acceleration due to gravity. So that means we also have acceleration can affect it. All right. And height or distance. Okay, so we've got these things about now if I mash together mass and acceleration, what does that give me?
Isn't it force?
Force, right? So force can affect it. Okay, that's another thing. Now, one of your questions asked you, and some people, like you're like, Mr. Raines, that's a trick question. It's really not. What I want you to look at and identify is this. Notice one thing we didn't write up here was time. Right? Everybody get that? Time was not written up there. Okay? If you want to jot these down as notes, this is notes. That's not a bad idea to have. Okay? This is good information. Notice time is not up there. So, if I run up the stairs, or if I walk up the stairs, if I go the same distance, have I affected my work? No. It's the same amount. Okay? So that's what I need to get you to understand first. This whole thing that time affects work doesn't happen. Time does not affect work. Put that over here to the side. Time does not affect work. Now, however, there is one thing that we haven't mentioned. What if the work and the force are not in the same direction? Like you're applying a force at an angle. What do we use? Y'all remember?
Cosine.
Yeah, cosine theta. We're going to do cosine theta if the force and work are at angles. Okay? So last thing to jot down there. Now, one of the things that I want you to get, number one on your lab, the back page of your lab. Okay? Number one on the back page. It asks you, if I start with a potential energy of 0, and I climb up the stairs, what's my new potential energy? Okay? Overwhelmingly, when people ask me questions about this, they have already written down that their new potential energy is 0. All right, tell me something real quick. I've got a scenario for you. Currently, what is my potential energy?
0.
Why?
Because you have no height.
Okay? I've done some work. Now what is my potential energy?
The
Well,
word
the
height.
height,
Times my mass, times gravity. Do I have some potential energy?
Yes.
How would I know how much potential energy I have if I don't know the height? Did I do some work?
yes.
Okay. Notice, what I need you to get out of this is that work is not only a change in potential kinetic energy, but it's a change in potential energy. Work is a change in energy, period. Okay? So in this case, you did work on yourself. You made yourself go up the stairs. That value on number 1 is the same value on the one on the back page because you did work on yourself to get you now new potential energy. So currently here, we'll just say whenever I get to this height, it gives me a 10 joules of work. Okay? To get up to here, I have to get 10 joules of work. What is my potential energy right here? 0. Now I'm going to do some work. What's my potential energy now? 10. How did you know?
Because the work was 10.
Because the work was 10. Okay? But now, let's change it up just a bit. What if, here's where it differs, and this is why I don't like your equation being this. Which this lab does it, and I know why it does it, and we just explained why it does it, but I don't like this. I prefer this. And this is why. Okay? If I start right here, we're going to say this guy was 10, so this guy is 6. Okay? What is my current potential energy?
6.
6. Now what is my potential energy?
10.
10. What was the work done?
4.
4. Notice, if you do mass times gravity times height, you will get 10. Because my height here is 10, right? Or it enables me to have 10. But it was 6 here. Because we said work is a change in potential energy. It only works on the steps whenever you start at 0. What was our potential energy on the steps?
Are you talking about?
No, on the steps. Out over there, right now, what is my potential energy?
0.
0. If I do this, what was my work done?
10.
10.
10. But over here, I started here, and my work was only 4. Does that make sense? That's why I prefer distance. Okay? Because we want to know, what did you actually travel? Because work, if I'm right here, currently, how much work am I doing on myself? None. Why? I'm not moving. I'm not changing my motion. Right? I'm right here. I'm doing no work. Do I have potential energy? Yeah, absolutely. I've got 10, according to the model that we just set a while ago. Right? When I come over here and I drop down, did I change my potential energy? Yeah, absolutely. Okay? In that process, did I have kinetic energy?
Yes.
Okay, then tell me, how come now I have no kinetic energy?
Because you're not moving.
Because I'm not moving. What stopped me?
It's still not.
The stool. Did the stool apply force to me to stop? Yeah. Absolutely. He applied a force on me to stop me in my tracks. Okay? Was work done on me? No, because it wasn't applied through a distance. It stopped me right then. Okay? So, hopefully we understand that now. When I change my energy, I've done work. Everybody okay with that? We good? Any questions? So, we should have answered 1 and 2 on the back of your page. If I want to know what my new potential energy is, what do I have to look at if I started at 0? Amount of work done, right? Well, whatever your work was on the first page, that's what your potential energy is going to be. Does it make sense? You with me, I hope?
Yep.
Okay. So now we got that whole worked out. I want to do something. I want to do a couple of practice problems with work. So pull out your notes and write work practice problem. Just to make sure we got it. Work practice problem. So the first mass is going to be 100 kilograms. The height is going to be 10 meters. The second mass is going to be 50 kilograms. And the next height is going to be 20 meters. I want you to compare the works. How do these guys compare, okay? What you need to do, I'm going to set a timer. I got a 2-minute timer I'm going to set, okay? I'll set the timer. When the timer goes off, what I want you to be able to do is explain to me how does the works compare and why. And I don't want to hear because that's the way the math works. Okay? I need to know that you have an understanding of this. Okay? So, figure out what is the work of this guy, what is the work of this guy. He is going to start at 0 and he's going to go up 10 meters. And he's going to start at 0 and he's going to go up 20 meters. Right? So it's an actual distance. It's not just height. I don't want you to spit back and say, Mr. Rains, you didn't tell me they were moving, so it's 0 and 0. No, there's actually going to be work done. They're actually moving. Okay? I want to know what will be the work of these two guys that have moved from 0 to 10 and from 0 to 20. And why? How do they compare? Okay?
It would be the same.
I'm going to set the timer. You got 2 minutes. Make sure you have an explanation to your answer. Again, we are live, so we do not want to be on film on my YouTube channel. And walk in front of the camera. I want to try to do this more often so that if you miss a day, you don't miss a day. Right? That's kind of the thought. So I'm going to try to do it more often now that I have my live.
This is confusing. It's like, technically, they would be the same once you work it out.
Technically, they're the same, and then you work it
Well,
out.
because you're halving the mass, but you're also doubling the distance. So it would, you're doing more but less, but then you're doing less but more, and they should equal out. But whenever you do it, you only get like 101 over here, and then you get like 9,810 over here.
Okay, well, I don't know what you're doing,
MGH.
but this times this is 1,000 times 9.81 should get you 9,810. So doing the math,
Then why did I get that?
this should be 101. This should be the same as this guy here.
Yeah.
Do that real quick.
100 times.
I've got about 20 seconds. Whenever I ask you to defend what you have said, you will be live. So if you're like, no, not me, then don't let me ask you. Okay? So when I say, hey, you want to share? No, I'm good. That means you're not going to be on the video. Okay? Otherwise, you're going to be on the video if I ask you. Okay? Does anybody want to volunteer?
No makers.
Are you going up there?
No, you're just going to say. I won't see you. You just tell me. What do you got? What'd you find out?
They're the same.
They're the same. Why?
Well, the first work you have 100, and the second one you got 50.
Okay, so the mass.
Yeah.
So which guy is going to do lift more mass or have a greater force on them? This guy. Okay, I like it. Specifically, twice as much force, right?
But you're
Okay,
doing less distance.
but less distance.
Vice-
Okay.
Vice versa, you're doing less work over a longer distance. So
Does everybody get what happened here? I picked this relationship on purpose. Okay, this guy here, I need you to understand that they're equal, right? They're equal. But how are they equal if this guy has so much more mass? Well, this guy went so much more further, right? He went twice as far. So when that happens, they're going to have the same work. Hopefully that makes sense to you. Okay? Everybody good? Can I move on to power now? Talk about power. What are the things that affect power?
time and distance. Oh no, work and time.
Work and time, absolutely. That's what we need to identify. So if I got this equation, I think this one's actually not working very well. If I got this equation, power is equal to work divided by time. The first thing I want to know is how are work and power related? That's the first thing I want to know. How are they related? I want you to think really quickly and give yourself numbers, okay? Whatever it may be. What happens when you increase the work?
Increase the power.
The power increases, right? So if you increase the work and the power increases, what type of relationship is that? If I increase this by 10, this guy's increased by 10. If I increase this by 5, this guy's increased by 5. If I increase this times 100, this guy's increased times 100. What type of relationship is that? Anybody know? If we graph it out, we'll start to see this. Oh, that's linear, Mr. Raines. Okay, yeah, but what does that mean? It's a direct relationship. Okay? Make a note of that. This is a direct relationship. Okay, this is what we mean. What if I went in here and I did this? How would that affect this guy?
The same.
Okay? Oh, Mr. Raines, that's not right. Okay? Say this guy's 10. We'll make that guy 5. Okay? 3 times 10 is what? Okay, divided by 5? 6.
6.
Okay? Now, what happens if I get rid of the 3? Well, we have to get rid of the 3 here, right? So then that's literally like this. Are you okay with that? I multiplied 3 times W. What did I do to my power? 5 multiplied by 3. I increase, so what would happen if I did this? 10 times W divided by T. What happened to the power? It's the same concept. A while ago I had 3, now I'm writing 10. Alright? 10. Remember my first power was 2. Okay, so I'll move this guy out of the way. 10 times 10 is 100, divided by 5 is 20. Okay? What do I need to multiply 2 by to get 20? 10 times W would make this guy be 10p. Right? Well, if I did 5 times W, that's going to make this be 5 times the original power. Right? It's directly related. Whatever we do to the W, that's going to be directly affecting that guy. And it'll be the same thing. Okay? Now, talk to me about time, though. Next one is what are, we said that was a direct relationship. How are time and power related? Okay? Hopefully you got this. This question asks you this. You go up the stairs, and then you go up the stairs again. The first time you do half the speed, the second time you do twice the speed. Or time, not speed. So the first time you do half as much time. Okay? The second time you do twice as much time. How is the power affected the first time? When you do half the time. Okay? Let's think about it. Write this equation out on your paper. I'm going to come in here and I'm going to say, all right, with that, I'm going to make my time be 1/2 the time. Okay? I'm going to have 1/2 of that time. For this to be the same, you're dividing by 1/2 here. So what does that mean you have to do over here? Divide by 1/2. What is dividing by 1/2? Times 2. So if I have 1/2 the time, then I have twice the power. You don't believe me? Let's do the math. Put some numbers in. Okay? Work is 10. Time is 5. What's power? 2. Okay? Half this guy. Well, all right. That means that it's going to be 2.5, right? Half of 5 is 2.5. Okay? So I'm going to say 10 divided by 2.5. What's that? What did I do to the power? I doubled it, right? What did I do to the time? I halved it. So this whole relationship, you should have seen this. On part A, you half the time, you double the power. Right? Your power probably was around 100 or 200. That means you should have had something around 400, 300, 400, 500 on part A. Okay? What happens if you double the time?
Less power.
Less power. Half the power. Right? Does it make sense? So this is what we see. The faster you do something, the more power. Okay, but Mr. Raines, that's a direct relationship. No. With speed and power, yes. But if I do something faster, what happens to my time?
Is low decrease.
Decreases, right? So that means that these guys are inversely related. If we graphed it out, it would look like this. Right? It would look like that. As time went by, power was inversely related.
So if you used half the power, half the time would be less power.
Half the time is more power. That's the opposite.
Just making sure.
Half the time is double the power, whereas double the time is half the power. Okay, so if you take longer, you're going to do less power. So what are the two ways? Okay? We're going to do me and blue. I used blue earlier today. Okay? Blue has more mass than I do. Okay? So when we start going up the stairs, me and him walk up the stairs together. We're talking about physics. And I'm trying to talk him into learning how to use physics to his advantage in football. Okay? Just having this good conversation about that. And so we're talking about it, we're walking up, we're going the same amount of time. Which person, when we get to the top of the stairs, has done more work?
Him.
Okay, so which one had more power?
Him.
Him. Why? Because he did more work. Right? What does Mr. Raines need to do the same amount of power and work?
Go faster.
Okay, so I need to either go faster, which would decrease my time, or I need to do the same amount of work as him. How would I do the same amount of work as him?
I mean, you could gain weight.
I could gain weight. What's another way I could do it a little faster? Okay, go more height,
Yeah.
right? What's another way?
Make him go a different speed.
Okay, that would still, we're talking about the work, but I appreciate it. But if he slows down, then our powers could be the same.
Yeah.
Okay? What if I tagged on a backpack? Throw some books in. Is my mass going to increase?
Mm-hmm.
Yeah, the work that I'm doing then is going to increase. Okay, so all of those are valid ways to make our power and work the same. Make sense? Can I get the idea? Any questions about any of that? Okay. Make sure that you can do this lab, or you can finish up the lab and turn it in. You got about 5 or 6 minutes left in class. I'm done. I'm going to turn off the live lecture.
You want the lab or you want to put in the box?
Put it in the box, please.
I'd get all of it.